Good afternoon, everybody. So thank you, everybody, for being here. Many thanks for attending the event today, hosted by ISF and titled Understanding Disease Resistance and Its Impact. We do have a panel of experts today, which will present to you different aspects of the work on disease resistance. And after all the presentations are complete, we will have a small session of Q&A where all the speakers will be able to address some of the questions that you have. It is important to highlight that the agricultural revolution of approximately 10,000 years ago intensified humanity's relationship with plants. Since survival largely depended on yield, early farmers would have selected plants based on multiple factors, including their ability to resist disease. Multiple plant disease recorded in ancient times were often attributed to supernatural causes, but the phytopathological observations can be traced back to the 3rd and 4th centuries BC. In the writings of Aristotle's students, Theophrastus. The advances in molecular techniques and genomics on the early 21st century has drove the discovery of numerous classes of genes that encode regulators of disease resistance and, of course, susceptibility. And now, to talk more about this topic, I would like to welcome our first speaker. She has a PhD in plant pathology and has been working in GEVES for 15 years as the head of phytopathology laboratory, with activities in seed health testing and evaluation of resistance of varieties. She is the chair of the ISF Disease Resistance Technology Working Group and the Easter Seed Health Committee, and also vice chair of VEGFIL, a French association for plant health. I would like to now welcome you, my esteemed colleague and friend, Valérie Grimault. Valérie, the floor is all yours.
Thank you, Rose. You see my presentation okay?
Yes, we can see it. Thank you.
Okay. So I'm going to talk today to you about the disease resistance, terminology, and plant health, and really what we are doing in the ISF DRT working group. So disease resistance is one of the components of plant health with integrated pest management, prevention, cultural practices, healthy seeds also, and monitoring and also control measures. Really one of these components to have healthy plants. Disease resistance tests are carried out for several purposes. First, to screen for genetic resources, for breeding also, and at the end of the process for registration and protection for the US or VCU in countries where it happens. And it's done always in the same way by a comparison of variety to resistant and susceptible controls, using protocols for resistance tests, which are reproducible, practical, and really also representative of resistance in natural conditions. So here you have some examples of the resistance tests which can be carried out. And the conditions to test go from the more miniaturized, the more controlled, and the shorter to the less miniaturized. So we have some tests in growth chambers that I like better because you control really everything. It's short and it's really miniaturized in greenhouses and in fields. But we have to know that we cannot do all the tests in growth chambers because in some cases, really resistance expresses itself naturally, really in field conditions. And in the past, we have been confronted to some misunderstandings when talking together. For example, I will give you just two short stories of what happened for us in GEVES. Once we had a customer who said, oh, my variety is resistant to fall 1, Fusarium oxysporum lycopersistion tomato, and could you test it and confirm? So we tested, and the variety was looking like that here, completely susceptible. So, okay, we talked a lot. And at the end, we discovered that he was talking about fall race 1 because he was in the US. And we were talking he was talking about fall race 1, but for us, fall race 1 is fall 0. And we tested with fall race 1 which for him was 4:2. So of course, his variety was susceptible to our fall 1 isolate. So big misunderstanding. Another misunderstanding was with Fusarium melon. We had a breeder coming who said it's FOM1 resistant. Okay, we test with FOM1 and all susceptible like that, for example. Talk again a lot. And we were speaking about the isolate, but he was speaking about the gene. Just misunderstanding. So how to deal to avoid those misunderstandings? And this group is including 15 members. I chair this group, and I have a big help of the ISF Secretariat. Rose is a member of this group also. And we have representatives of all the seed industry and the seed chain in this group, with seed companies, seed federations, initiatives for reference material, and also examination offices. And our aim is to go to a consistent terminology to describe reaction of a plant to a pest. So we have defined some definitions, pathogen codes, and differential host tables that I will detail a little more later. So first, definitions. Definitions are very important because we need to speak the same language and understand each other's. So we defined susceptibility, high resistance level, and intermediate resistance level. So 3 levels of interaction and answer of the plants to a pest. Susceptibility, inability to restrict the growth. Resistance, ability of a plant variety to restrict the growth development, and all the damages compared also to susceptible varieties. And in this resistance, we have defined 2 levels. One high resistance, where it highly restricts, and one intermediate resistance, when it restricts, but a little less, and an intermediate resistant variety may exhibit a greater range of symptoms or damage compared to a high resistant one. So you see 2 levels. And now these terms are really used by seed companies in their catalogs, but which is very interesting also in DUS studies and CPVO protocols. And there is another word, tolerance, that we don't use for the plant interaction with the pests. We use tolerance only for abiotic stress, just to make it different. It's a long way for people to use really our terms of susceptibility, high resistance, and intermediate resistance. But it's improving. You will hear some virologists in the scientific parts who have more a definition of tolerance, like multiplication of the virus, but no symptoms or no yield decrease, which is a different concept. So some examples of how our levels are defined. For example, in potato virus Y resistance in pepper, it is in this case a high resistance level. And in CPVO and UPOV protocols, it's defined as resistant present or absent. Here, resistant present. They don't use high resistance, just resistant. Here again, in UPOV protocol, absent present. And it's a very clear-cut test, susceptible, high resistance. Another example where for the same crop, we have a combination of high resistant and high intermediate resistance. It's nematodes resistance for a tomato, where you see here that we needed to have a scale with controls, a susceptible control, intermediate resistant control, and high resistant controls, and rules of decisions compared to these controls. And what does it look like in the official protocols? A susceptible level, a high resistant level, and in this case it was called moderately resistant. So these three levels are defined. Now Pest Codes. We use the word pest because it's all for pathogens, nematodes, and insects. We have used the FAO definitions. We also have defined an order, well, suggested for catalogs, just to rank the resistance, starting with viruses, bacteria, fungi, insects, and at the end, nematodes. It's just a suggestion, but to go for uniformity and consistencies in the different catalogs. And the codes, we have based them on internationally recognized institutions for taxonomy. And we defined some guidelines for codings of the pest. For example, for melon necrotic spot virus, it's the first letter of each word. So it will be MNSV. It's a coding which is really very common in virology. An example in Fusarium, first letter, Fusarium oxysporum from special melonis, first letter for Fusarium, O for oxysporum, but here we have many Fusarium oxysporum, so we added one letter just for the forma specialis. And we also coded races, form with 2 points, 0, 1, 2, which is different from the gene form 1 that we were talking a little earlier. Another example for Fusarium oxysporum form special Lycopersicii. You remember our misunderstanding with the US and the Europe? Well, we could not recode starting from 0 because it was so much used to use for 1 in the US. So we said, okay, for new pests, we will start codification at 0. But when it already exists, let's just make it a little more precise, but by saying for 0 EU is the equivalent of for 1 US. So we add these letters just for consistency and understanding each other. Bremia lactusae, we have this little sign to say it's a resistant from race 16 to race 36. And here again, you see EU because the codification in the US is different. Up to now, we have 28 vegetable species where we have pest codes. And we define also differential host tables. Because when a resistant variety is cultivated, the pests evolve and we see new races appear. And it's very important to have a differential table to be able to identify the different races. Here you see an example for Fusarium P, where you have the races 1, 2, 5, 6, and the differential hosts. And you can see little signs here, asterisks. That's where there is a use in the seed sector. So it means that we are sure that we have validated these ones. These ones, we indicate them, but we also indicate that we have no use of them in the seed sector. So you see again, susceptible, high resistance, for example. And the very clear-cut also response of our differentials. Up to now, we have 28 tables, and we started with a peer review of the literature and indicating the use in the seed sector. But more and more, we are validating these tables nowadays. There are also collaborations with the validation which are done by initiatives like IBEP for Bremia, where, for example, the last epidemiological survey was done on more than 100 isolates over the last 4 months, and there are criteria for nomination of new races. Codes also for differentials with CEST codes, And when I prepared my presentation, we were up to BL36 EU, but from 1st of June, we have gone up to BL37, a new race which has been nominated and which will be included in the ISF webpage also. Validation also by Matref, which is a French network having 82 host pest combinations. And also validations with the CEST, who has several white papers that are indicated here. And what we do is that we take all the information from all these validations to make our DRT table. This one for tomato mosaic virus on tomato, where you see here, there are differentials coming from the validation of Matref and others coming from the validation of CEST, so that we have a table which is more complete. We also collaborate with IBEB, for example, for validation of Fusarium oxysporum on lettuce. The validation of fall 1 has already been finalized and is in the differential table. And at the moment, we are working on fall 4 to define a new type isolate and new differentials. We work also on powdery mildew on melon to update the isolates, the differentials, and the coding system, which at the moment is very complicated. We worked in the working group on 38 isolates and 15 candidate differentials. It's under progress. And another project on Fulvia fulva, on tomato, with new isolates overcoming the CF9 gene, and also a plan for a new coding system. It's also a project under progress. And we also have new projects under discussion. We collaborate in research projects like Harmonization for having a network to have access to validated reference material. A new project which has been submitted to CPVO on TOBRFV and aphids on melon. And just to conclude on my presentation, for us it's very important to have some harmonization of terminology and the improvement of disease resistance to go for a better plant health. And all our research projects on disease resistance will have some concrete, how can I say, conclusions or will be used for our definitions, for our differentials of stable, for our pest codes, and also to exchange the scientific information and to communicate on our work. Thank you for your attention.
Thank you very much, Valérie. That was a very great presentation, and I learned a lot from it. And it's important that you highlighted the work on the initiatives, the collaboration that exists between there, and some of them under the umbrella of the ISF DRT working group. So thank you so much for that. And now I would like to welcome our next speaker. He will talk about reliable, transparent, and uniform communication on resistance claims. He is a pathologist in Bayer Crop Science. He holds a bachelor degree in agriculture science and over 30 years experience in the vegetable seed industry. He's starting with breeding of sweet and hot potato peppers and since 2001 plant pathology. I give you all my dear friend, Tom Allersma. Tom, the floor is yours.
Yes, thank you, Rose, for this introduction. So after you all heard Valérie talking about the definitions and how to harmonize the terminology, well, this is an important step that is needed for the communication of the resistance claims to people that are not pathologists, so the customers and growers that use the products of the breeding companies to grow their products. And in this presentation, I will share you how to harmonize the different initiatives to make sure that we have the same understanding of the conclusions, because in the bioassays, resistance claims are based on reproducible data, based on a protocol and statistical significant differences that lead to conclusions really from a scientific perspective. However, in a communication to customers, these conclusions are transformed into an interpretation, and the perspective of the customer is different from the scientific perspective, because for the customer it's also important what is the actual level of resistance. Is the resistance stable? So does it not only holds on in the growth chamber but also on the field under different climatic conditions? And so this perspective has to be taken into account. And to give you an example, this is how this looks like. You see a full data set that comes out from a bioassay, and that is turned into a description on the available resistances, or on an intermediate level, for in this case for oidium and nematodes, or to a high resistance level for different viruses and fungi. And of course, these variety claims give you a description of the characteristics of the variety. But at the same time, it's also a promise to the customer on the risk that he or she is going to have when growing a product with these resistance claims. And here it is very important to make sure what is understood in, for example, a high resistance or an intermediate resistance. So here I put forward an example. Looking at the picture at the left, you see, assume that there is a product which is under normal conditions. The most products lead into the field to only, without any measures, to let's say a 10% survival rate. So that means that the grower has to take a lot of measures to make sure that there is sufficient yield. If there then comes a new product on the market which has a surviving rate of 50%, from a scientific perspective, you say, this is really much more resistant. And would it be possible to claim this resistant? But when you look from a grower's perspective, then he would argue, 50%, I still need to take a lot of measures to secure that I have a yield. So for me, the product is not resistant. It's definitely better, but I would not call it resistant simply because I cannot limit the number of measures that I take. So from a grower's perspective, 50% survivors is still susceptible. When we look at the right side, then the same situation, but then moving from a 50% survival rate to a 90% survival rate. Again, from a scientific perspective, absolute a clear step in resistance. And also here in this case, a grower can limit the number of measures to take to get a good yield on his product. But still then there remains the question with how do we call this resistance level? Because you can say it's 90%, it's pretty high. So let's call it high resistance. However, there's still a 10% yield loss. So is that high resistance? Because 10% is quite a lot on the field. So maybe the grower will consider this as intermediate resistance. So, and this is not only a theoretical discussion. As I show here in the next slide, for example, let's take the claim on tomato spotted wilt virus in tomato and pepper. Tomato spotted wilt is a plant virus. It's transmitted by trips, and resistance is there. It's a single dominant gene, both in tomato and pepper. And the resistance is based on hypersensitivity. So, which means as soon as the plant cell recognized the virus, it will lead to a fast cell death, and though preventing the virus for further growing and multiplication in the plant. So it's a very effective resistance mechanism that really gives a black and white resistance. However, the same resistance can also happen in case of very heavy infection on the fruits, which you show in the picture. You see dark necrotic spots, And still that resistance, also when it's in the fruit, it's highly effective. It really protects the virus from movement within the plant. However, the grower will face that he has a product which is not marketable. So then, well, what is then the correct claim for it? From a scientific perspective, you say it protects perfectly to the virus, but at the same time, this resistance does not protect to a yield decrease and a risk of yield decrease for the grower. So therefore, it could also be considered as an intermediate resistance, and this is also what's currently claimed in the market for this type of resistance. Another example is the nematode resistance in tomato. Also here we have a resistance which is single dominant and is highly effective towards nematodes. However, there are multiple populations of nematodes that are able to overcome the resistance of MI1. And as right now there are no official races described, we are not able to differentiate and to clarify this in our claims. So there is a risk for the grower that in the soil in which the crop is standing, that there is a breaking population available or present, which overcomes the resistance, and also there's also a serious risk that the population is not fixed, that you have a mix of breaking and non-breaking nematodes in the soil. So in both cases, it will lead to a yield decrease for the grower, and this is not something that can be seen on forehand. So also here, despite you have a good black and white resistance, still there is a risk for the grower that there is a yield loss due to the presence of non-characterized nematode races. So also here, to avoid the risk and to make sure that the grower understands that there is a risk of yield decrease. Also here, the claims are put on intermediate resistance. So as said, to avoid that there is difference in the interpretation and that it's very clear what is mentioned, the industry had made an alignment on how to do the interpretation. So to avoid the confusion and make it more transparent to customers what is really needed, what is really mentioned by a specific claim. And there is a whole framework of initiatives that is working together to make this transparent for throughout the whole industry. And well, I've put you here some examples. Well, Valérie already mentioned the International Seed Federation, which has described the definitions, use the same codes, and make sure that we can characterize the races. There's also the European Seed Association, on which I will come later on to, who has a system to harmonize the commercial claims, and also the UPOF, which is harmonizing the claims for the national listing. And how does this work together? I will explain this in the following slide. It starts. Let's put the seed companies in the center. The seed companies make resistance claims, and these claims are used for two purposes. On one hand, it's used for the national listing and plant variety protection, so for the variety registration. On the other hand, on the other side, it's used for communicating the commercial claims to customers. And well, I put this in two groups because, well, although it goes from the same resistance claims there's really a specific goal for each of the two type of claims. Where for the national listing, the main goal is to describe the differences between varieties to make sure that these are unique. Whether for commercial claims, the goal is to describe the variety and what is the risk that a grower has when growing such variety. In both cases, well, it's not the communication of the disease claims for national listing and commercial claims. It's not a direct communication, but there are two groups of initiatives that are working to this. Going to on the left side, for the national listing, the claims of the industry will be tested by the examination offices like Naktuinbouw or Matref, which I mentioned earlier. And these examination offices will confirm that the claims are indeed the correct ones. And examination offices, well, they do not have developed protocols for themselves. They use the protocols by CPVO, which is the European board that is covering all the examination offices, and these are the protocols are derived from the UPOF guidelines. On the left side, you see, well, there's the ISF group that makes sure that the terminology that is used and the pathogen codes, that these are the ones that are used by the industry, and then also the claims are harmonized within the EuroSeeds resistance tables to make sure that also here the claims are aligned. And to make sure that this communication is going correct, you will see that on all different levels, there is an interaction between the different initiatives and the industry to make sure that what is meant by, for example, an intermediate resistance or a high resistance, that this is also well understood, and that a claim is not based on completely different protocols that are used. So there is a lot of harmonization ongoing, and this is not only into ring tests that are frequently done between partners, but also for different initiatives, for example, to harmonize on the controls and differentials that are used. And here I put some forward, for example, an isolate collection from Bantam, from Matref, and CIPC. And well, the next two speakers will go for sure much deeper into this part and explain the work of the examination offices. So I will focus now on the others, on the industry side, where also here there is a number of ring tests ongoing and have been done, also to make sure that there is alignment between the industry, between the examination of between the partners, to make sure that even if we mean the same by the same variety claims. And not only there is ring tests ongoing, but there also are different initiatives to make sure that the coding and naming of the pathogens remains up to date. We have different initiatives, for example, the Bremia Evaluation Board, the Working Group on Peronospora. But there are more, like for example, the Plantum Working Group, Phytopathology and activities in UFS. The goal of all these groups is to describe upcoming or new variation on the pathogen side, to characterize it and then name it and add it into the ISF nomenclature to make sure that this variation is clear and understood. And as a few examples that you see from industry initiatives to harmonize and to characterize claims, well, these are a couple of examples. For example, a release from the Bremia Evaluation Board to describe and to officially announce that there are new races identified and now being described, and based on that, the industry can indicate whether or not the products are resistant to these new races. In the middle, another initiative from the Plantum Working Group, Phytopathology, on the characterization of tobacco ash virus in pepper, and also on the right, and presentation, a poster from that was work that was done by the UFS, the French Pathology Society, in this case on describing races on MNSV in melon. And what all these three have in common is that it describes new variation within the pathogen site that can be used to bring more information and make a more concrete claim to the customer on what the resistance that is claimed, what's the value of that. Also, as mentioned earlier, another example from harmonization is done by the Euroseeds group. This is where you can see that for all the different pathogens with use of the ISF abbreviations, codes, and the common names, there is a level described, and this level is linked to specific example varieties that are listed here in the last column. And these example varieties are used by the different, by all the companies, to align the resistance level of their products to see, well, if it comes close to the example variety, that it also will, that their products will also get the claim of those example varieties. And in this case, also the resistance level is harmonized among the industry with the goal to give transparency to the customer. And an example of harmonization ring tests by the industry is, well, we have different ones which are mentioned. For example, fall race 4, mentioned by Valérie earlier, powdery mildew and melon, but also on the level of claims. And these activities done by Euroseeds, for example, oidium in tomato and stemphylium in tomato. Stemphylium was a project which was done last year. And also this was on a ring test by the different companies and also including the examination offices, and with the goal to see whether the differences in resistance level that are observed, whether there is a need to make a different claim on this. And the conclusion from that project was, for sure there is a difference in the resistance level, but there is, on the resistance side, there is quite some variation, which is clearly different from susceptible. And in this case, for the goal of the examination offices to describe between resistant and susceptible, it's very clear. Where for the industry, it's still under discussion whether the differences that you see in resistance level, whether these are valuable and does it make sense for a customer to describe and to separate in it. Because under a low, you can imagine that under a relative low infection pressure, well, even let's say a lower resistance is still fully effective. So in this case, the industry need to further discuss on whether it's on what will be the final claim and or this will be separated. Of course, this the goal to harmonize this has definitely an advantage, and well, which means, well, all the information, all the references are made public, so everybody can read on the internet what are guidelines, what are the definitions, what are the example varieties, and also explanations on claims. For example, within the ISF there are explanatory notes for Tobamo virus, for tomato yellow leaf curl, and so on. Always the goal to explain resistance claims and variation, genetic variation that is present. Also characterization projects, which are mentioned earlier also by Valérie. And the main goal of this whole is to avoid confusion by the growers, and also increase transparency. So it will be good. It will be possible to compare varieties from different companies and look on what the claims are made, and well, these claims can be compared and are not as they are harmonized among the different partners. This whole network that I just showed you, well, it's coming to become more global, adopted. Its main activity started in Europe, but you see that already in 2011, from the US, the Center of Plant Pathogen Strain Identification joined also those initiatives and started harmonizing with, and very recent also the Asian countries from the Asia Pacific Seed Association. They joined also the ISF DRT group, also with the goal to come to a more global adoption of the whole harmonization framework. And this will also give you a perfect way to standardize on example varieties, on controls, and so on. And with that, I would like to finish with the statement that although for resistance claims, the raw data are not shared to customers, because of the framework that is behind, the customers can have trust in how we communicate our claims, and they can make the decisions that benefit to their business, which is growing vegetable products and delivering quality products to us as the consumers. And with that, I thank you for your attention and would give the floor back to you, Rose.
Thank you so much, Tom. That was very enlightening. Thank you for clarifying a little bit more about disease claims and all the initiatives that coming from the industry to be able to harmonize this very important topic. So it's very much appreciated. Thank you for that. I would like to just give a little shout to all the people who has already put in comments. Thank you for all the participants that are coming from Tunisia, from Tanzania, and from Brazil. So thank you so much for joining us here. And please, after the last speaker, we'll have a small Q&A session. So if you have any questions, I suggest that you already put already put online, and so we'll be able to address this afterwards. Now we're going to be moving on to our third presentation. And for that, we'll have Wim Sangster. He is a vegetable crop specialist at Nactonball, and he will talk about disease resistance in the US testing. Wim has a bachelor's in plant breeding at Wageningen University, and he has been working for more than 30 years at Nactonball at the variety testing department. In 1988, he started as a DOS examiner, and since 2002, he has been working as a vegetable specialist and involved in post and maintenance control and coordination, DOS testing several crops, especially Solanaceae, Brassicaceae, peas, and beans. Wim, the floor is all yours.
Yeah, thank you very much, Rose. And I'm delighted to talk about, again, another aspect of disease resistance after Valérie talked more in general and explained what we are doing in ISF and what is disease resistance about. Tom explained more about communication to the customers, and I will handle about different aspects of disease resistance in the US testing. This is an overview of what I will be talking about. Especially we are talking about disease resistance in vegetables, because that's where it's most important. In the past it was almost only in vegetables, and now you see also that disease resistances are being developed also in ornamentals, but still in the US testing we are mainly looking at disease resistance in vegetables. I will talk about what are we doing, when do we do it, why do we use disease resistance testing, how do we do it. We do biotests, but we also develop marker tests to improve our procedures. We develop new tests in coordination with all the international world and seed industry. And the most important thing, we can only do this when we have international cooperation, because as the US examination offices, we are not developing ourselves, almost not, but we are cooperating to have the best knowledge to use in our DOS testing. So the first thing is what was being told already, that we have breeding in vegetables especially, and new resistances are developed, but also new races are coming. So new resistances against those new races are being incorporated in new varieties, which are for us applied for listing and plant breeders' rights. Important to know is that behind those new developments can be different genetics, and that's important for us because in the US it's important to know if it's a qualitative or a quantitative characteristic. Qualitative means it's absent present, and quantitative it means that there is a kind of level of those characteristics. And that's important, as Valérie and Tom also indicated already. Especially indicate here, I would like to see what is important, because UPOV says what is a good characteristic to use in the US testing. And when you see here that in the definition is stated that the characteristic results from a given genotype. And that's, for us, it's very important because, as said already, there are behind are the genes which causes the resistance. We are not looking for the genes, we are looking for the morphology, for the what is the result of the genotype. And that's what we are looking to in the US testing, and that's why we have to do the biotest, because we can only check the result of the genes in the varieties. Of course, there has to be sufficient variation between varieties, otherwise we have no characteristic. And very important, and the most important thing is that the characteristics should be capable of precise definition and recognition. And this has all to do about harmonization. We have to look at the same thing as examination offices. An examination offices in the Netherlands is testing for a kind of resistance for a claim. We need to have the same outcome as when those applications should be applied in France. Otherwise, we would have very difficult cases and there would be no comparison. Uniformity requirements should be fulfilled. That means that when you have a variety where all the plants are the same, they should be all the same also and have the same explanation of the disease resistance characteristics when we test it in the biotest. And of course, stability. The variety has to be stable when a new reproduction is produced, and it means that in future the variety will look the same. Another thing that sometimes we are confronted with quarantine regulations, and for us as the US examination offices, it is sometimes very difficult, because then in that case it's difficult for us to test the resistance which is incorporated in the new variety. So we have to cope with it. So this is some general things which I would indicate. So when do we test in variety testing? There are different occasions. As said already by Tom, he mentioned that we have the US testing for listing, that's for marketing in the European Union, and we have plant breeders' rights, and that handles about 90% of the use of disease resistance in our variety testing process. On the other hand, we have requests by companies, and they can request just a test. Please test the seed lot to be tested against some resistance, or they send in some race and we determine what race it is. That's about 10% of the questions. And then somewhere in the middle we have also, because we are an inspection service, that has not to do with the US testing, but that's in fact is the maintenance control of the varieties which are on the market. And we test about 100 seed lots which are tested for maintenance control or post control, and that's requested by the department or the inspection department to the variety department. Why do we include disease resistance in variety testing, in the US testing? We do it because it's a kind of combination. We do it because it gives us a lot of efficiency. If we use resistance characteristics which are mandatory to be published in the description of the varieties, we can use a more efficient way of the US testing. Because if it's mandatory, it means that all examination offices has to report about it, but it has the consequence that we need harmonized control of those claims. As said, it should be ridiculous if at Tuinbouw we should have the conclusion the variety is resistant, and in another country they should have concluded that it's susceptible. So it's all about harmonization. If we have those harmonized claims, it's possible for us to use variety resistance as grouping, which means that we are not comparing in the field a resistant variety with a susceptible variety. And that saves us a lot of space in the field, and saves us a lot of work. And we can do it only because if we are sure that the claim done by the company is controlled in a harmonized way and that we know that it's really the result. So if we are sure the result is there, we can use that grouping because we use only the comparison in the field for the varieties which are resistant. We compare with the resistant one and susceptible one with the susceptible one. As said, also we have to check uniformity. And since those disease resistance characteristics are in the protocol and we have to report about it, the same for morphological characteristics, we have to test that uniformity, and we only can test that when we do a biotest. So uniformity has to be checked in resistance test if we want to see if the variety is uniform for those resistance characteristics. A very specific aspect is that sometimes applications are done which are morphologically completely the same, but only are different in disease resistance characteristic. So in that case, we really have to check the difference between those two varieties. And that can be in an obligatory disease, but it can also be in other disease. Like, for example, we have varieties where they have claimed that the only difference is TYLCV resistance, and then we have to check it. And that sometimes can be difficult because TYLCV was a quarantine disease, and I will mention in the further on in the presentation how we did it. I told you already that sometimes we use it also as a check for inspection, and we use it when for service when companies ask resistance testing for resistance test or race determination. How do we work with resistance testing? I told you already that it's all about harmonization. If we have a different outcome in 1 year from another, that's ridiculous, but also from an examination office to examination office, we should have the same results. And we can only have that when we have harmonized protocols. And that's why in the EU we are working according to the CPVO protocols, which Tom mentioned already. And in those protocols we have harmonization about different aspects. There is indication of which inoculum we have to use, the controls and standards, how we carry out the test, which period of the year, circumstances, temperature, humidity, all that things. Observation scale is very important. I will tell you more, like with the nematode, what Tom called, where you have susceptible, intermediate and high resistant varieties. So we have to take into account that scale also with different controls for each level. We have to validate if it's a good test or not. That's very important for us. If the controls do not meet the requirements and do not give a reliable result, we cannot validate the test. So we have those critical control points which have to be in order, and if not, then the test cannot be used for the DOS. So we have the standardized protocols, and within those standardized protocols, we are also a little bit fine-tuning, and then we have the working instructions for exactly for our tests. Because every examination office is a little bit working different. As said already, some tests can be done in the greenhouse. We mostly work in greenhouse. Other examination offices more work in test, and some tests has to be done on the field because a greenhouse or another test is difficult to do. So that's the fine-tuning what we do for the test within Nactuinbouw. As said, that harmonization is very, very important, and that's why we have always standard inoculum using in our test. Mostly it's coming from a collection which is established by Plantem in the Netherlands with cooperation by Nactuinbouw. It's about 90 isolates. Either if it's not in that collection, we can use inoculum from elsewhere. For example, the Mother F, where Valérie talked about already, and which will be explained by Sophie also after me. If not, we have our own collection where some isolates are in to use in other tests which are not used so many times. So I told you that plantum collection, we have about 90 isolates. It is many different aspects, bacteria, fungi, viruses, nematodes, and it's limited, as I said already, to the vegetables with resistances. And the focus in that collection is on the compulsory characteristics in the US, because they are so important to be harmonized, tested. And Nactambo manages the backup collection, and we also give to other parties when they request. For the members of the collection, it's for free, but when you are not a member, but a third party, you can also get those isolates, but then you have to pay a limit. And this is all in a contract since 2005 when this isolate collection was established. On the other hand, we have the French framework, which is not only about isolates, but it's also about the seeds to be used in those resistance tests. And as told already by Valérie, we are trying to put together an international harmonized system, which is called the Harmonization, where we want to put together all this system to get an even more international harmonized system to do the resistance tests. Of course, we have our quality objectives for all our tests here at Nactambo. As said already, we have the CPVO standards in the protocol, where we have the number of plants, we have our uniformity standards, we have the standardized controls in the test for resistance susceptible, but maybe also for intermediate resistance, and we have our decision criteria when we have quantitative systems, where sometimes we need statistics, and we have thresholds, standard thresholds, to separate between levels of resistance. Very important. Very important is also that it's good to realize that we always have to be ready. We have our year-round tests. I mean, we're not always doing all the tests, but we have a schedule we are doing. But companies can also come to us for services to ask for those, for doing those tests. And this means that we have to be able almost year-round to do those tests. So we have to monitor pathogenicity and identity of the nuclei to be used, and otherwise we cannot use it. And we have to need sufficient facilities like greenhouse or cell or other equipment to be able to do those tests year-round. And to mention again, we have our protocols, but those protocols can be improved always. We have harmonization for ourselves in the Netherlands, but we have also the international harmonization. I call the Harmonization call. We have the Harmonization projects within the CPVO, which was about disease resistances in many systems, like Fusarium in tomato, like nematodes, like melon, where there was harmonization of the resistance testing in those crops and those disease systems, where we talked about how we could do the test for the best to improve harmonization in doing that test. And sometimes it's necessary to look for alternative standard varieties when we are doing tests, because normally those standards which are mentioned in the protocol should be available, but sometimes they are not available anymore. And what we do then, we can use alternative standards, which we check and validate with the standards mentioned in the protocol, and then we can use the alternative standards for our own test. So it all has to do with the quality and harmonization of doing those tests and using them for the US. Here I would like to share some examples about biotest in fungi, viruses, bacteria, nematodes, and insects, and for each to explain some important aspects. As you see here, this test about Passiflora fulva, here it's very important. It's a leaf disease, and here you have to keep the right humidity and temperature. especially the humidity for this disease is very important. And that's why we have a tent, which we can close in the beginning of the test to keep the relative humidity. And if we do not that on a controlled way, then the disease cannot develop. So it's very important to notice that keep the protocol in a standardized way to get the good results for this test. Fusarium tomato, which is, as all fusariums in many crops, many species, you can see differences in expression of the disease and of the resistance. Here, for example, you see a susceptible variety where you see some plants show if it looks if they are resistant. And this has to do with how the disease behaves in the plant. Sometimes you have what is called incomplete penetrance, and then the disease is not penetrating in the plant completely, which shows then that the plants do not show susceptibility or resistance as expected. And in those cases, will explain further, we can make use of markers to see if the disease-resistant gene is present or absent in those varieties. And this especially can put light on the problems which we encounter in the disease resistance test. And that for us is very important because many times we see difficult cases and we have to repeat the test and we have to get to find explanations why the symptoms are expressed as they are expressed in a certain test. And this is especially for the fusariums that uniformity might be a problem, and it's different from test to test. So that's why it's so important to see what's going on and what's the explanation. Here is the expression of the nematodes, as already told, where we have different levels. Susceptible varieties, high resistant varieties, and intermediate. And where we have, for that case, we have to use those threshold varieties between susceptible and intermediate and between intermediate and high resistant. Very important. The Pseudomonas in bean, where we have also different levels, and it has not to do with different genes, but it more has to do with also the expression of the resistance, and also therefore we need good borders between susceptible and resistant to include in the DOS test. Another example is aphid resistance in lettuce, where we have to do with insect resistance, and there is also important that you use the right clone of that aphids, because in lettuce, but also in melon, where you have also the aphid resistance, the resistance is just restricted to a certain clone, and that clone can change, like the races in fungi. So we have to use the right clone to check the right claim in the variety. Very important. Now, I talked a lot about biotest. And that's because, as I said, in the US, we are strictly bound to the expression of the characteristics in the phenotype of the variety. But more and more, we are seeing that we also can use markers to demonstrate resistance of varieties. And we can do that because we have a golden rule that we only use markers when they are in the resistant genes, and also that we intend to demonstrate that the marker is present. If the marker is absent, we cannot be sure that the variety will be susceptible, because other genes conferring resistance to that varieties might be present in the variety. So only when we find the marker, we are able to say that the variety is resistant. If we don't find it, we are not able to say that the variety is susceptible. So in that case, we need a combination of the biotest and the marker test. And also, it's important to see that the biotest is always decisive, because for UPOF, we still have to do with phenotype and not with the genotype. At present, we use a few marker systems, especially in tomato, where we use the marker for tomato mosaic virus and for TSWV. And we have developed one for Fusarium, but it's still not officially accepted by CPVO, but we can still use, as I said already, when we have problems in doing the biotest. And a recent one, which was accepted by CPVO, was LMV for lettuce. So in this case, we can combine resistances, especially in tomato, to easily detect resistances in new varieties. We are also developing, as I said, because in tomato, when we make a combination of more marker tests, it will be still more efficient to use markers in the US testing in tomato. So we are, at the moment, we are looking ourselves in an internal project to markers for Passiflora fulva. And in for CPVO, as mentioned by Valérie, we also have a project about TOBRFE, and we also developing markers, trying to develop markers for that. The only problem here in developing new markers is that the information from companies mostly cannot be used. And that's because it's competitive information from companies which they do not want to share. So this means that although there is a lot of information already available at the companies, we cannot always use this information. So we have to go back maybe to the patents, which are filed, for example, about TOBRFE, and we can find information of that resistance genes and markers in the patents, and we try to develop our own tests. We have two different systems of the marker test. We use the old-fashioned test, which were gel-based, but we are developing now the Tacman tests. And this is especially so important for us because, as I said, we have more and more markers in tomato. We can combine them in a multiplex system where we only have to isolate DNA, and we can all do the tests in one round. So it's much faster, and especially it's much cheaper for us. I told you already, all the time, new diseases are coming, new races are coming, and we have to develop new tests. Like the TOBRFE, we have developed our own tests, and we have to do with infection and quarantine, what I mentioned already. And I told you, for example, about the TYLCV resistant variety, which was the only difference with the old variety, which was susceptible to TYLCV. And as it was a quarantine disease, we were not able to carry out a disease resistance test. But the Spanish Nactambo, so to call it, which is called the INIA, they developed a TYLCV test with the GMO Agrobacterium, and they were able to carry out that test for us. So by testing the susceptible variety and the resistant variety, we could differentiate between those two varieties, which we could not differentiate in the field because morphologically they were the same. So by doing this modified test with TYLCV, we could see that we had two different varieties, and we could list that new variety. As mentioned already also by Tom and Valérie, it's all about cooperation, because in the US testing, we need harmonization. We need to have the same results for all examination offices. That's why in CPVO we did the HarmRes projects. We have the IBEP, where internationally they are working about evaluation of new isolates of Bremia evolving in the new season. And when new races are evolving, new varieties have to be bred to incorporate resistance in those new varieties, and they are applying those new varieties to us and again. So there is very important cooperation to say, okay, those new isolates have to be incorporated in the DUS system or not. The same is for spinach, where we have also a working group. Also, when new races are coming, there is cooperation to nominate those new races and afterwards decision to incorporate in the DOS testing or not. Now, we have said already, on the basis of all the working in disease resistance is the ISF working group, which was explained by Valérie, and Ton also said already that the CEST collaboration in US also more and more is incorporated in the whole system. So very important that international cooperation. And here you see in short where we are. In the middle, we are in examination offices, where at the right, you see the industry, where we have ISF, ASA, and Plantum. It's important to harmonize everything. Matref between examination offices and the seed industry. And at the left, you see more the scientific part of the international playing field, with universities, where they do all research about genetics, taxonomy, phytopathology, and in between the CEST, which is more scientific based than. So it's in between the scientific part and the DOS. So this is the last conclusion about disease resistance testing in the US, where you see this is the playing field, and it's there because, as said, harmonization is the very most important topic, because all examination offices have to do the same. Thank you very much, and I will have you hand over to Rose again.
Thank you so much, Wim, and that was very enlightening. You explained really well the role of the examination office, the importance of international harmonization, on the work that you guys are doing, the biotests on the different types of organisms. Thank you so much for that. And I would like now to go to our final speaker of the day. She has been working in JVS for 15 years in the phytopathology laboratory as a manager of resistance variety team, with activities that explore the evaluation of resistance of varieties. Sophie Perrault is here with us today, and she will talk about the activities from the French perspective. So she will tell us all about what is happening in JVS. Sophie, the floor is all yours.
Thank you, Rose. My talk is about evaluation of disease resistance with a focus on the French activities. GEVES is the French examination office, funded from 3 partners organizations, the French Ministry, INRAE, and SEMAE. Mission of GEVES are on varieties, for registration on the French catalogue, and for protection at the French level and European level. And also on seed, for support on the seed chain, especially for certification. And GEVES is the national reference laboratory for detection of GMO and quality testing of seeds and propagating material. GEVES is also assigned for the national coordination of plant genetic resources. And as you can see, GEVES is involved at different levels of seed sector, from research and selection to marketing. GEVES has different partners, national partners as the French Ministry of Agriculture and INRAE for fundamental research, CTPS for registration of varieties, INOV for plant breeder rights, but also SOC and SEMAE for certification of seeds and varieties. And international partners as CPU and NUPOV for the US, and ISTA and ISHI for seed quality, and counterparts for research, harmonization, and collaboration on different subjects. The study of varieties is carried out by the Variety Study of Department, SEV, from GEVES. For the US, for the morphological characteristic, including also resistance tests, and in this case, tests and analyses are conducted in the GEVES units. For VCU, for evaluation of the added value of the variety, including also disease resistance. And in this case, trials are conducted by a network managed by GEVES. Results of DUS and VCUS tests are used for plant breeder rights and for registration by the CTPS. CTPS includes a disease expert commission for different species groups, which assist and guides genetic programs and progress. Results are used also for varietal control for certification, and GEVES is also involved in the sector support with analysis including resistance test and production of inoculum. And in this case, tests and analyses are conducted in GEVES units for breeding, screening of varieties, and evaluation of varieties before registration. The activity of disease resistance at GEVES are for evaluation of resistance of variety to different pathogens and pests, setting up and maintaining a strain reference of collection, including more than 2,000 of isolates, which are available if requested at GEVES, for conducting research program with French and international collaboration, for epidemiological studies on different pathogens, for training students and members of seed industry, for bibliography, and for publication and communication. Resistance tests are performed for genetic resources, breeding, registration, protection, as explained by Valérie by comparison of the variety to resistant, intermediate resistant, and susceptible controls. Protocol used for resistance tests following the CPVO protocol. And if they are not existing, it could be internal protocol. And these protocols are reproducible, practical, representative of resistance. And as explained by Wim, it could be biotest protocol or DNA marker test. DNA marker tests are used when they are well correlated with biotest, and it could be used for resistance or susceptibility evaluation, but also for evaluation of homogeneity of a variety, for example. A part of test of evaluation of resistance of varieties are performed at GEVES in field with either natural infection or in artificial infection. In case of artificial infection, the production of inoculum is performed by GEVES with reference isolates representing of the predominant isolate present in field. As you can see, there are different species tested for resistance in field. The activity of evaluation of resistance of varieties is also performed in controlled conditions, in greenhouse or in a climatic chamber, with 75 host pathogens tested, which represents more or less 150 host race of pathogen. In the table, you can see in red the new test from each year, added each year. This new test come from transfer of tests previously carried out by INRAE or new pathosystem developed at GEVES. 25 species are work in controlled conditions: vegetable, field crops, fodder plants, oilseed crops, and strawberry. Half of the analysis is performed for registration or plant breeder rights, and the other half of the tests are performed for seed support. And tests are performed on bacteria, fungus, virus, aphids, and nematodes. To perform a resistance test, we need different material, reference material as seed of control and differential, which have to be validated, available, and healthy. Also, reference isolates validated regularly in tests, available, stable, and representative of the predominant pathogen present in natural condition. At GEVES, 250 pathogens and pests are used as reference isolates for resistance tests and are available if they are requested in the GEVES collection. It's for vegetable and for field crops. This reference material is used in a reference protocol, including inoculation method, notation scale, interpretation rules, and this protocol come from UPOV guidelines, CPVO protocol, or internal protocol validated, repeatable, and reproducible. For vegetable, we can use reference material which come from MATREF. So MATREF is a network created in 2002, including public partners, GEVES and INRAE, and private partners, 12 seed companies. The objective of MATREF is to manage reference material, controls, differential host, and pest and pathogen strain. All this material is available at MATREF, and you can find all the information on the GEVES website on the MATREF page. MATREF include 11 species of vegetable, 48 diseases, which represent 82 host pathogen or pest combination, 202 controls and differential, and 358 batches of seed lots. GEVES is also involved in conducting research program for harmonization of methods with counterpart breeders to obtain more reproducible method and to avoid any discrepancy between official results and claim of applicant. Setting up of improving method for disease resistance, for new pests, new race, as for example the new Brema race 37, or for emergent pests due to the reduction of chemical treatment. Validation of method to propose reliable methods recognized at an international level, CPVO, UPOV, epidemiological studies, and new pathosystem. These are examples of research programs in which GEVES is either coordinator or partners for DUS and VCU or for epidemiology studies or terminology. GEVES is involved in epidemiological studies, in HIBEP for denomination of new Bremia races or evolution of differentials, in ISF Working Group DRT, with the participation of different ring tests for validation of differential tables, validation of new ways or new differentials. GEVES is also involved in Rust Watch for wheat rust diseases and is involved in monitoring of sunflower downy mildew, oilseed web clubroot, and wheat common bunt. To finish, I will present you two examples of new development of resistance tests for registration in the French catalog. The first one is the evaluation of resistance of common wheat to common bunt using an early resistance test. In this new test, 4 controls are added, 2 resistant and 2 susceptibles. A reference strain of Tilesia caries is used, representative of predominant virulence present in field, and a protocol was validated based on a correlation of field results. The protocol is start with an artificial infection of seeds and a sowing in control condition. At 2-leaf stage, a small part of the plantlets is taken for a DNA extraction and a qPCR. Results of variety in study are compared to controls to define level of susceptible of resistance of the varieties. And the second example is the evaluation of resistance of pepper to varieties to Meledorigine incognita. In this case, 3 levels of resistance are defined, and for each level there are a reference control, a resistant one, an intermediate resistant, and a susceptible. the reference strain of Meloidogyne incognita is used, and a protocol was validated, also correlated with rhesus in field. After a first step of multiplication of the nematodes and checking of the presence of mature eggs, the contamination is done by a mix of small cut part of fruits of the multiplication varieties in soil and the sowing of varieties and test performed in controlled conditions. The notation is done by evaluation of presence of galls on the plantlets and comparison with the controls. Thank you for your attention.
Thank you so much, Sophie. That was a really, really interesting presentation, and I believe that I have learned a lot. So thank you so much for all the speakers today. And now we open for our Q&A, and I can see that there is not many questions yet, but I would like to start with a question from myself to you all. So next week, the International Plant Protection Convention will conclude the International Year of Plant Health. That was a huge landmark. It highlighted a lot what is plant health, and let's not forget, plant health starts with seed health. I would like to hear from some of you. Perhaps, Valerie, you could start. What it was the significance for the work that you do, especially with disease resistance, to have IPPC recognize plant health?
Well, for us, it's very important because really it means that the recognized plant health as a very important topic. And what we have also to have in mind is that plant health is one component of what is called One Health, which is also human, animal health, and also for the environment. So it's all a chain where plant health has a great importance. And in that, our action for disease resistance, is a central part. And well, in this year, we also had our little, let's say, virus topic issue, and pests are always evolving, and we need really to be very focused on all this evolution of pests and be ready to have disease resistance answers to that. That's why we worked a lot on TOBRFV this year to detect it and to be able to move some healthy seeds, but also to be able for us examination officers to characterize new varieties and to know if they are resistant to this new virus.
No, that's excellent. It is important that we remember that there is the focus on bringing on plant health is really to highlight all the work that has been done, the importance of plant health that there is for food security, and we can never forget this. I just would like to, Tom, would you like to add something to what Valerie said?
Yes, sure. I think last year it's one of the big advantages. What I see is that the society becomes more aware of the activities that are going on within, especially the agriculture group, and the efforts that are being done to make sure that that people can have healthy fruits and food. And nowadays, sometimes you get the impression that the consumers, they think that the stores, that these are the providers, that these are delivering the foods, that they are making the food, and they forget that there is a whole industry behind that has its specific issues to make sure that with pathogens and that the supply of food is not so self-explaining as that and as it is expected. But that's good that there becomes more awareness that this part of the industry is important for all.
Yeah, well spoken, Tom. And I really hope that we will have a full adoption and implementation of the International Day of Plant Health, and that we're waiting for that. Hopefully will be adopted, and then from next year, 12th of May, we'll have the first International Day of Plant Health, which is fully supported by the ISF, and we have already made this well known to FAO and to IPPC. I'm aware of the time, but I do have one little question, and I would like to address to Wim, and there was something that Valérie mentioned, emergent disease. Emergent disease is a huge problem we have now. She mentioned this tiny little virus, which has been causing a few headaches to a lot of seed companies. Wim, as an examination officer, what is this impact of not just this little virus, but tobacco viruses in general? This is a problem. It is more and more emergent disease, and there's a specific genus of virus. It seems to become quite a few. They are breaking old resistances. And so what is the direct impact on the work that you do when we have this emergent disease coming?
Yeah, what you see is that companies indicate already that they are working on resistance, and we see it. We see patents coming, we see claims coming. We have already the first varieties in application where the resistance to disease is claimed. And we have also had questions already from companies, please, can you as examination office include the resistance to theography in the description? And we said, okay, not we can, because it's new and we don't have any harmonized system to test it. So we have to develop this. And it's good to realize that companies realize, and when they are developing those new techniques, new resistances, and including in new varieties, which will eventually come to our examination offices, that it's good that they realize that they have to come in advance to us as examination offices to share the knowledge and to make it possible for us to include it in the protocols for the US testing, to be able to include the information in the description of new varieties. And we need cooperation with the companies, because they have the information which is available for the new resistances. And we need that information to develop the new methods to include in the US testing. So this is from the resistance part. The other part is, of course, that we have to be more and more sure that when we are carrying out our tests and field trials, that we are aware that we keep a very good security to keep those viruses away from our field trials. The same as the companies has to be very careful about. Because if we have a trial where this virus should come in, we have to destroy, and it has a huge impact, because in a normal tomato trial, we have a glass house with about 250 tomato samples, and in that trial will be 50, 60, 70 new applications. And if we have to destroy such a trial, this has a huge impact for all the applicants which have applications in the trial. So this has a great impact also for our procedures, how we work with diseases and with clean greenhouses and so on.
Oh, that's
so
great.
on both sides. Yeah.
Thank you so much, Ben. There is one question from the audience, and this is for you, Valérie. So if you could answer that, perhaps maybe in 2 minutes. So this is, can symptomless carriers in case of virus be considered under the tolerance category? Valérie?
Well, let's say in the virologist definition, yes, that's what they call tolerance. In our case, we would more put it under the intermediate resistance definition. But that's something that we will be very careful, particularly for the TOBRV resistance. We have already had discussions about this type of category and where to put it. That's why, for example, in the protocols that we are planning to develop, there will be not only symptoms observation, but also detections in the leaves of the plants which are tested to see if there is some virus accumulation or not. And maybe there will be different levels.
Okay, no, that's really good, very clear, Valerie. So I think we have already run out of time today. So I would like to start to finalize this webinar by starting to say thank you so much for the speakers we have today, to Wim, to Tom, to Sophie, to Valerie. Thank you so much for being today, for your excellent presentations. Thank you for everybody who came to attend and watching us. And I would like to remind everybody that we will carry on talking about emerging disease. We will be talking about the TOBRV again from the 5th to the 7th of July on the International Seed Federation Virtual World Seed Congress, where we're going to have a special panel where I'll be moderating, where we're going to carry on talking about this very important virus and, of course, the impact that there is on the movement of seed and the seed industry as a whole. Please register for free. And for today, I would like to say thank you very much to everybody. Stay safe, stay healthy, and until the next time. Take care, everybody.
Thank you.
Yeah,
Bye-bye.
thank you.
Bye.
Bye-bye, everybody.
Bye-bye.
Hello to everybody. I wish you a very warm welcome. Today is an important day for ISF and I hope also for you, because we are opening the registration for our ISF Virtual Congress, which is from the 5th to the 7th of July. It's a unique opportunity to engage between you, but also you with us. Registration is open for free for everybody, ISF member or not member. Be part of the journey, our journey together to resilience, which starts with seed. And on top of this, we will be in a wonderful studio here and nearby. That means new opportunities of engagement, even more exciting to meet you in these times. Take care, see you soon, and don't forget to register.